Hi there, I'm John McMillan, and welcome to this edition of PCB Tech Talk, the podcast where we'll be talking about design tools, the EDA industry, and the questions that you're asking. I'll be bringing in special guests from time to time, including subject matter experts and EDA industry leaders. So be sure to subscribe to this podcast. Let me know the topics you'd like to discuss, and if you'd like to be my guest, right here on PCB Tech Talk. I grew up on the east coast of Central Florida, a few miles inland from the Intercoastal Waterway and the beach just south of Cocoa Beach, for people who know that area. Growing up close to the beach, naturally, lots of friends had surfboards in their garage, and a few points in time I tried surfing, several times in fact, but it was not really my thing. Skateboarding, on the other hand, sidewalk surfing that is, was. That said, I'm a big fan of surfing. In fact, I enjoy watching many of the World Surf Tour events online and follow my Florida favorites. I was recently blown away when I received a post to a VR, a virtual reality video, of some of my favorite surfers in Tahiti. I clicked on the video, and my smartphone was immediately transformed into a window with a 360-degree world view. What I saw was stunning. I could spin my phone and look all around, anywhere I wanted, up and down, follow the action I wanted. You felt as if you were transported right into the center of the action. Looking everywhere was truly an amazing experience, and I'll post a link to this video I'm referring to in the podcast notes. It really is incredible, how 3D graphics and 3D visualization are becoming more and more commonplace in our daily lives. From movie theaters to 3D TVs to 3D printers, and yes, to 3D views in software too. Software particularly for computer-aided design and engineering environments like mechanical, architectural, and of course electrical design are just more commonplace in providing users views of designs that can be both seen and interacted with like never before. So having a 3D design environment for printed circuit design particularly provides designers and engineers with the ability to take what in the end is a three-dimensional assembly from a flat 2D view into a true photorealistic view of the design. What were attributes for component height and Z-axis clearances have taken on a whole new meaning. Z-axis constraints, once only reported as a clearance violation, can now be viewed and explored and corrected in a whole new way. In my recent blog post, I touched on 5 cool advantages of a 3D environment for PCB layout, and I'll provide that link in this podcast notes as well. The first advantage is placing accurate component models in 3D, like step models, giving designers immediate visual feedback. One example of this feedback is being able to detect shadowing concerns for tall components that may impact wave soldering. From tall pin headers used for mounting daughter or mezzanine cards to SIM and CPU sockets, 3D visualization brings PCB component placement to a whole new world. The second advantage was that with these accurate 3D models, the component silkscreen outlines and even reference designators can be placed most accurately. Even when multiple sources of supply are available for a component whose land patterns are identical, may have component bodies that are slightly different. With 3D, designers can visually check for accuracy in any loaded configuration. It's really important to make sure component bodies don't inadvertently overlap reference designators or discover when they're accidentally overlapping pads or solder mask clearances, for example. It happened to me some years back. I placed the land pattern for I think it was a SOIC-20 on a design. One of the alternate sources of supply on the bill of materials was loaded, and the component body length of the available part was longer than the land pattern silkscreen, so it resulted in part of the silkscreen getting overlapped. 3D photorealistic 3D views really do enable designers and design teams to review the PCB silkscreen from a whole new perspective. The third advantage I've spoke about was the ability to incorporate 3D models of the mounting hardware, including screws and washers and standoffs, even heat sinks, into the 3D view. This really helps to ensure that there are no surprises when it comes time to mount the PCB in an enclosure or on subassembly or otherwise. You can easily, visually discover a mounting hole that should have been plated for a chassis ground connection or otherwise, or perhaps you've detected that the BOM, the bill of materials designated flat washer, actually has an outside diameter that overlaps a trace in time to correct it, perhaps by moving traces or by changing the part in the bill of materials to a washer with a smaller outside diameter. or however you decide to resolve the problem. Discovering and fixing simple issues that can potentially create big problems later, and the ability to incorporate mechanical hardware and even be able to try out different styles of fasteners in the 3D layout really does add a whole new dimension to both PCB design and MCAD collaboration within PCB design. If seeing the layout in 3D weren't cool enough, the fourth advantage of the 3D environment can be a really big benefit, and that's the ability to validate physical interface components like connectors. The ice maker in my refrigerator stopped working a while back, so we called in a technician. He showed up with a control PCB that had no less than 15 vertical connectors on it. I mean, from the profile, if you're holding the board like a piece in your hand, it looked like a model for a small city of skyscrapers. Being aware of mating physical interface components, big or small, is a huge advantage. I expect most PCB designers have seen SMT, surface mount technology, connectors, and headers that have the same LAN pattern for both the male and female versions. Bringing in the actual component models for connectors, headers, LEDs, switches, and so on can really help to ensure that there are no unexpected surprises during assembly. And here's another really cool part. Even mating connectors can be included to ensure that no interferences with the PCB's components are detected, like when connector housings are bulky, or if they include latching mechanisms, or other features that were not fully known or visibly identifiable during component placement. The fifth advantage really brings virtual prototyping to printed circuit design by enabling designers to bring in the actual enclosure and mechanical piece parts like brackets, board stiffeners, and RF shields, for example, can all be imported into the 3D view to ensure that all the necessary clearances are met. From making sure correct solder mask clearances are correct to preventing shorts when mechanical parts like screws are mounted, and knowing that everything from the PCB subassembly to its installation will go smoothly and as intended, all help to ensure installation and final assembly success. These are just a few examples of some of the advantages of working in a 3D environment for PCB layout, but there are also other features and capabilities of a 3D PCB design environment that add even more value. For example, you can use a split screen view when designing a PCB and get instant visual feedback of the component placement in the 3D view. Display controls enable you to choose whether the 3D display is to drive or follow the 2D view. So when you zoom in or out, you are getting immediate, accurate visual feedback. And if you want to take it to the next level, if you have dual monitors, you can even dedicate one monitor to the 2D and another to the 3D view. Also, performing the actual component placement in the 3D environment to improve or balance the design from a whole new perspective than possible from just a flat 2D design. The 3D display is not an all or nothing view either, so you can control, that is, turn on and off the specific objects. That is, you can choose to display and explore specified objects. So for example, let's say you don't want to see the traces or the component pads or the silkscreen. Specific objects can simply be toggled on and off as needed. That goes for components too. So if you just want to see the PCB itself, that is the bare board with top and bottom traces and pads with just the silkscreen and solder mask, you can have the display you want right in front of you of a photorealistic 3D view of what the fabricated PCB would look like. There's no mistaking the 3D layout environment for printed circuit board design is really cool, especially when it's intelligent. It goes way beyond that. You can even explore and specify clearances based on your 3D constraints. Online DRC, design rule checking. These rules enable you to check and provide graphical feedback that shows you any violations of the constraints during component placement. This, along with the batch DRC of the entire board, all help to ensure that you are designing with confidence and that you are meeting your design constraints at all times. If you see spacing that concerns you and want to check it out, you can even take measurements as if you had a PCB in your hand and a pair of calipers. There really is a new level of confidence with design clearances that a 3D environment provides. All of the things I've been describing are huge advantages for PCB design in a 3D environment. But there's another feature that brings in a whole new view to PCB design. And it really is a cool display feature that's only available in the 3D environment, and it's called a cut view. A cut view enables designers to actually navigate through a cross-section over the surface or through the internal layers of the PCB design itself. So if you can imagine diving into the printed circuit board, seeing within its cross-section cut view the plated through holes and vias, seeing the internal connections of the pad stacks and etch, or HDI pads, and essentially explore the stack-up of the design. The 3D environment is unique. It enables PCB designers to visualize the design at any angle, even viewing it through layer stack-up, import exact step models, import the mechanical case or other elements, and explore with cut-through views with custom graphical control. You can check both batch and online 3D constraints and clearances. You can follow or drive from either the 2D view or the 3D view, measure distances between different board level and mechanical objects. You can export PCB assemblies in multiple formats, even collaborate with MCAD. If you've never experienced PCB layout in 3D, I encourage you to visit pads.com/try and request a free evaluation of the Standard Plus product. I'll put the link in the show notes. And once you experience it, I think you'll be hooked and won't want to look at PCB designs without it. Having 3D layout capabilities brings tons of value when they are well integrated into your PCB design tool. Being able to take information from the Z-axis helps you design your layout better from the start and lets you design higher quality PCBs, both electronically and mechanically. With 3D design, you have incredible control over the design intent, better communication with mechanical engineers, and ultimately better quality PCB designs. So again, if you've not experienced PCB design in 3D, I hope this podcast encourages you to check it out. If you are familiar with 3D PCB design, but may not have experienced some of these capabilities I've talked about today, again, I encourage you to go to the links in the podcast notes and check it out. As always, be sure to check out all of the podcast show notes. There you'll find all of the links that I've referred to during this podcast, as well as our email address where you can send us your comments and questions. I'm John McMillan, and thanks for listening. And be sure to subscribe to this podcast on iTunes or your favorite podcast app, and catch the next episode of PCB Tech Talk.